Hello everybody, WeiEn Physics here and welcome to another episode of Physics Speedrun. In today's video, I will again try to finish 20 completely random multiple choice questions within 20 minutes. Of course, I will also try to explain the thought process behind completing these questions and so that you can use this knowledge to your advantage during the exam. And if at any point you think I'm going too fast, remember you can always just pause the video, go back to the start of the question and repeat it as many times as you want to. Or you can also control the speed of the video using YouTube's own video settings. So without further ado, let's begin. I'm going to start my timer right now. A block of aluminium with a mass of 110 grams and temperature of 27 degrees is heated until it reaches 100 degrees Celsius and is put onto a block of ice. 21.6 grams of ice melts and becomes water. Calculate the specific heat capacity of aluminium. So when the aluminium is heated, a certain amount of heat goes into the aluminium, right? And when you move the aluminium onto the ice, all the heat that went into the aluminium will now come out and go into the ice to melt the ice. So we can say that mc theta, which is the heat that went into the aluminium, is equals to ml, which is the heat used to melt the ice. So the mass of aluminium here will be 0.11. We want it in kg. C is what we're trying to find. Theta, the temperature difference from 27 to 100, that will be 73 degrees of difference, is equals to the mass of ice block, so 21.6, that would be 0.0216 multiplied by the latent heat of ice, which is given 3.36 times 10 to the power of 5. So if I put all this into my calculator, 3.36 times 10 to the power of 5 times 0.0216 divided by 73 divided by 0.11, I'll get 903.8. So closest answer will be 904 joules per kilograms per degree Celsius. Next, which of the following graphs shows a relationship between volume and temperature for a gas that obeys Charles' law? So we know, okay, I've got nowhere to write it. Okay, so P, the triangle works like this, P, V, and T, right? So Charles' law would be when the pressure remains constant, so only V and T, right? So V over T, I'll get a formula that is V1 over T1 equals to V2 over T2. Okay, and as you can see here, the temperature and the volume, they are actually directly proportional. Okay, imagine I make V2 and T2 a constant. I'll get V1 is equal to a constant times T1. So they're directly proportional. And so they have to go up. But this one is wrong. Even though it's a directly proportional graph, it's wrong because the temperature is in degrees Celsius. Okay, so we need the directly proportional graph for temperature in kelvins, which is not possible here. So the best graph that we can use would be C, right? Whereby the 0 point is actually behind in the negative portion. This would be negative 2, 7, and 3. Okay, and if you change it to kelvins, then for example here, you should have a directly proportional graph, right? Because for the gas laws, your temperature should always be in kelvins. Okay. Next, determine the pressure at the bottom of the swimming pool given the length and the width of the swimming pool are 8 and 4 respectively. The height of the swimming pool is 5. So the width and the length actually doesn't affect the pressure from the pressure from the water, because liquid pressure is only affected by the height, right, or the depth. So we don't care about the length and the width, so we only want the height. So pressure is equals to mgh equals to h rho g, right? So h is the height, that's 5 meters, and rho, that's given 10 to the power of 3, and g is 10, right? Now I believe you have to add the atmospheric pressure also. So atmospheric pressure would be about 10 meters of water, right? So you can either make this 15, okay, you can either make this 15, right? Or you can just add another 10 to the power of 5, right? So this is 5 times 10 to the power of 3 times 10, okay, and then plus 10 to the power of 5, right? So I'll get 150,000, which would be 1.5 times 10 to the power of 5. Okay, next one. Which of the following shows the correct relationship between pressure, force, and cross-sectional area? So P is equal to F over A. So F and P are directly proportional. If F goes up, P goes up. So we have to look at, okay, so reduces and reduces, this one is possible, okay? Let's say if it's constant, if the force is constant, then A and P, they are inversely proportional. As A goes up, P goes down, right? So if A increases, pressure should decrease, so that's wrong. If A reduces, then pressure increases, that is correct, okay? But let's look at the other one. Cross-sectional area increases, pressure reduces, force reduces, correct? Cross-sectional area increases. Yeah, okay. D would be correct because D is the relationship between all of them. For example, between pressure and force. So if one goes down, the other goes down. What about between pressure and cross-sectional area? So if cross-sectional area increases, then pressure also goes down, right? So D would be the one that is correct in this case, okay? Next, figure 28 shows a tennis ball being hit towards the wall. The ball approaches the wall with an initial velocity of 6 and rebounds with a velocity of 5. So calculate the change in momentum if the mass of the ball is 150 grams. So the change in momentum will be mv minus mu, I believe. And mass will be 150, right? I'm just extracting, I'm just factorizing it out, yeah? So I'll get v minus u, the final velocity minus the initial velocity. So let's say I take going to the left being negative, right? And going to the right being positive, okay? So this would be negative 5, okay? Negative 5 multiplied, minus initial velocity, that's positive 6. Okay, so this would be 11 times 150. So 150, 150 should be 0.15, yeah, because this is in kilograms. 0.15 times 11, I'll get negative 1.65 kg per meter, kg meter per second. Okay, so that is D. Next, shows an egg being dropped on a block of cement. Which of the following materials will prevent the egg from breaking? Of course, we want something that is soft to increase the impact time, right? So as to reduce the impulsive force. So we want foam. Okay, foam. Okay, next. A fishing boat with a mass of 500 kg is being pulled by 2 buffaloes as shown in figure 35. So the mass is 500 kg. Each buffalo pulls the boat with a force of 500 newtons and the forces act at an angle of 60 degrees to each other. Calculate the resultant forces. So if the angle between them is 60 degrees, that means the angle between one buffalo and the, let's say, the normal is 30 degrees, or between the horizontal is 30 degrees, right? And if this force here is 500 newtons, I can calculate the equivalent horizontal force for one buffalo, for just one buffalo, right, to be 500 newtons cos 30 degrees. Okay, so 500 newtons cos 30, that's 433. That's for one buffalo. So both buffaloes would be 866 newtons, right? So the resultant force 866 newtons. The answer would be D. Right? Next, figure 36 shows a box with a mass of 8 kg placed on an inclined plane at an angle of 30 degrees. A force of 50 newtons pulls it up along the surface. What is the acceleration on the box? So basically, I'm trying to find out what is the downwards force caused by the weight itself. Okay, so we can see here this is downwards, right? And then we have a reaction force this way, and we have a parallel force. So that's what I'm trying to find here, the parallel force here. Okay, so 30 degrees, that means this is 30 degrees, right? So this force here would be sine. Okay, the weight sine 30, and the mass is 8 kg, so the weight would be 80 sine, because I'm assuming gravitational acceleration is 10. 80 sine 30, that would be 40 newtons. Okay, so there's a downwards force this way of 40 newtons. Upwards force is 50 newtons, so the resultant force is 10 newtons. And we know that the resultant force F is equals to ma. So 10 newtons is equals to the mass 8 times the acceleration. So A would be 10 divided by 8. It would be 1.25. Is that correct? Yes, I think that is correct. 1.25. Okay. Now, the next question. Most flying objects such as aeroplanes have wings in the form of aerofoil. Okay, so aerofoil, if you don't know, is something shaped like this, and the air on the top will go faster and the air on the bottom will go slower. Okay, and so when you have a faster airflow, your pressure will be lower according to Bernoulli's principle, and the slower airflow here will cause a higher pressure, and so the difference in pressure will cause a net force pushing the aeroplane up. Next, figure 32 shows the density of liquids P, Q, R, and S. So which of the liquids has the highest density? The highest density will cause the hydrometer to float the most. Okay, so definitely liquid S, right? Because the higher the density, the more buoyant force it's going to have. Okay, so yep, donkey. Next, Aslan drives at a velocity of 72 kilometers per hour. What is this velocity in meters per second? Very important, you need to know how to change from kilometers per hour to meters per second, because that is what you need. That is the units you use for your Suvat equations, right? So it's very simple. Kilometer per hour can be written this way. To change from kilometers to kilometers to meters, I just have to multiply 1000 on the top. And to change from hours to seconds, I just have to multiply 60 for minutes and multiply another 60 for seconds, right? So basically, the top number needs to multiply by 1000 and the bottom number needs to multiply by 3600. So 72 kilometer per hour would be 72 divided by 1. Multiply by 1000 at the top and multiply by 3600 at the bottom. Basically, it is 72 multiply 1000 divide by 3600. I will get 20 meters per second. And a vector quantity is a quantity that has magnitude and direction. Okay, magnitude and direction. A scalar quantity is something that only has magnitude, no direction. Okay. Next, figure 10 shows a set of apparatus used to determine the specific heat capacity of aluminum. So what is the assumption in the experiment? Now, of course, for a lot of heat problems, right, the assumption is always no heat is lost to the surroundings. So just by screening through the answers, I can basically guess that the answer is D. But let's just make sure. Heat is absorbed by the aluminum, definitely. Okay, I don't think that's an assumption, right, because that is true. Aluminum achieves thermal equilibrium. Eventually it does achieve thermal equilibrium with the heater, right? That is also true, it's not an assumption. No friction between thermometer and the aluminum block. I don't think friction has anything to do with this experiment here, right? Okay, so yes, our assumption will be no heat is released to the surrounding. Okay, next, figure 12 shows a cylinder filled with air at a temperature of 25 degrees Celsius. So the same cylinder is then heated to 50 degrees Celsius. Which of the following information is not true? Number one, the pressure of air doubles. Okay, so the relationship between pressure and temperature is P1T1 is equals to P2T2. So if I move this around, P1 over P2 is equals to T1 over T2. Now, if I were to write it as 50 degrees Celsius and 25 degrees Celsius, I'll definitely get a ratio of 2. So that means it has doubled. But because when I'm doing my gas laws, my temperature should always be in Kelvin. So this is not 50 divided by 25. Okay, it is actually 50 plus 273, 323 divided by 298. And I can see here definitely this is not 2 times, this is not double the amount, okay? So A is actually wrong, right? Other than that, velocity of the molecules increases, yes. Kinetic energy increases, yes. Okay, that's why. And weight is used to maintain the volume, yes. Okay. Next, a metal is released from a building that is 50 meters high and the temperature increases by 4 degrees Celsius after it falls from the building. By assuming there is no heat released to the surroundings, calculate the specific heat capacity of the metal. When the metal is falling, okay, it had potential energy in the beginning, and as it falls to the ground, then it loses all its potential energy. So we're assuming that all the potential energy gets converted into the heat energy that increases the temperature. Okay, so we can say that mgh, which is the potential energy, is equals to the heat energy, that's mc theta, right? M can cancel each other off, so we don't need to know what is the mass. The gravitation acceleration, that's 10, height is 50, C is what we're trying to find, and the temperature difference is 4. So C here would be 500 divided by 4, that's 125. So the answer is C. An electric heater with a power of 200 watts is used to heat liquid with a mass of 500 grams for 2 minutes. If the specific capacity of liquid is 4 times 10 to the power of 3, what is the temperature increase in the liquid? So the electric heater, all the power from the electric heater is assumed to be used to heat up the liquid, right? So energy from the electric heater, it will be PT, right? Power times time in seconds, yeah? And this will be equals to mc theta, which is the heat energy that went into the liquid. Okay, so power, that's 200, time is seconds, 2 minutes will be 120 seconds. That is equals to 500 grams, 0.5. C given 4 times 10 to the power of 3. The temperature increase, that's what we're trying to find. So 200 times 120 divided by 0.5 divided by 4 times 10 to the power of 3. Temperature difference is 12 degrees Celsius. B. Okay? Right. Given the focal length of the concave lens is negative 25 cm, what is the power of the lens? We know that P is equals to 1 divided by focal length, where your focal length is in meters. Okay? So 1 divided by negative 0.25. So I will get 1 divided by 0.25, that is 4. Negative 4 diopters. Okay, so donkey. And what are the characteristics of the image if the object is placed at 2f, where f is the focal length of the lens? I'm pretty sure this is the drawing is correct. Okay, so I'm just going to assume that this drawing is correct and get my answer based on the drawing. Okay, so you can see here the image is definitely inverted, right, meaning upside down. And the image is real. Okay, when you have a lens, if the image is on the other side of the lens, then your image is real. Okay, if it goes back to the same side as the object, it's virtual. So real, inverted. Okay, and you can see that it is same size, right? It is about the same size here. Okay, if you measure it, it should be the same size, right? Because if you put your object on 2f, it will appear on 2f at the exact same size. So real, inverted, and same size. So the answer here should be C. Okay, oh, last one. Good. Lim walks 12 meters due west from a point O. Okay, so this way, 12 meters. And then 16 meters due south, this way, 16 meters. What is the total displacement? Displacement is the shortest distance, so I'm trying to find this, the hypotenuse. Okay, so that will be square root of 12 square plus 16 square. Oops, sorry if it's a bit messy. Alright, so 12 square, that's 144, plus 16 square, square root the answer. That would be 20 meters. B. And lastly, which of the following correctly identifies velocity, kinetic energy, and momentum? So velocity is definitely a vector. Okay, that is what makes it different from speed. Speed is a scalar, velocity is a vector. So this. Kinetic energy, all energy are scalar quantities. Okay, And lastly, momentum. Momentum is definitely a vector because we know that momentum comes from mass times velocity. And if velocity is a vector, then the product of it with anything will also form a vector quantity. So momentum is a vector. So the answer here is D. Alright, so I think that's done. Let me stop the time. Woo! 19 minutes 27 seconds. Close. Right, I had only about 30 seconds left to spare. Right? Because I think I spent a little bit time on this question here, yeah? Okay? So, yeah. That is all for this episode of Physics Speedrun, right? If you enjoyed videos like this, if you enjoy watching me stress out, okay, and try to rush questions, then give it a like and subscribe to my channel for more physics related content. So I guess that's all for today's episode of Physics Speedrun, right? I'll see you in the next video. So and remember, never stop learning.